All right, so we're going to keep working with our unit circle today. And before we actually get to answering this question, which is finding a tangent of a specific angle, I want to just give you a quick little summary of some things we've kind of been talking about. So I'm just going to use a space here. You could write this wherever. But whenever you're doing these problems, you're going to have a reference angle located somewhere. So whatever angle you get drawn in, you'll have some angle, and you'll draw it down. You'll have your reference angle right here. And what's really key to understand is that this point is like some x and y value. Well, that x is this number, and that y is this number. And so because of that, hopefully you're starting to notice some patterns here. When you do like sine of theta, sine is opposite over hypotenuse. It's always just equal to y. And when you do cosine of theta, it's just adjacent over hypotenuse, so it's just x over 1, which is just x. So now when you start thinking of these other functions, like tangent, for example, or any of the other ones, tangent would be opposite over adjacent, so it's going to be y over x. And as you start putting all this together, you start getting some shortcuts in terms of how to understand how to do these things. And even if you add in the other functions like your cosecant, secant, cotangent, they're simply going to be the inverses of these. So like 1 over y and 1 over x and x over y. And so we're going to put all that together today to kind of tie all the pieces of what we've been learning into one kind of major concept. All right, so let's look at this here. Again, technically no new information today. Everything we're going to be working with is stuff that we've been working on throughout this whole trig unit. So this says find tangent of negative 5/6 pi. All right, so let's draw where that would be. So negative means we're going clockwise. 5/6 pi means not quite to pi, but 5/6 of the way. So it's going to be like here. All right, drop that angle to the x-axis to make your reference triangle, and then figure out what this would be. This is going to be 1/6 of a pi, or in other words, 1/6 of 180, which is 30 degrees. You'll notice these are always going to be one of our special right triangles. That's kind of what these are built on, what we've been working with and learning with. So this is a 30, 60, 90, which means this is 1, this is 1/2, and this is root 3 over 2. Every single time, those are your lengths in a 30, 60, 90 on the unit circle. All right, so now what's tangent going to be? Tangent of, negative 5 pi over 6. So because we are in the third quadrant, these are negative values. Negative, negative. Because you're going left and you're going down. So they both have to be negative. So when we go to do this, we're going to do tangent, which is opposite over adjacent. So this is going to be negative 1/2 over negative root 3 over 2. Okay, so dividing fractions. The shortcut for dividing fractions is instead of dividing by this fraction, multiply by its inverse. So think of it this way. You got negative 1 over 2 times 2 over root 3. All right, in that case, the 2's will cancel each other out. And, this is negative. The negatives will cancel each other out, so it's going to become just positive. And we have 1 over root 3, which we've played this game before. If you've got a root in your denominator, rationalize it. So that's going to be root 3 over 3, and that's going to be our value. There you go. All right, a little bit tougher, a little bit more involved in coming up with that and thinking of it and working it through. Now, you are going to notice that these are going to be the same values you consistently get. When you're working with a 30, 60, 90, like that over that is always going to be this number. So you're going to kind of see this come up a lot. Same thing when it's the other way around. If, let's say this had been the 60, then it's going to be this part over this part, and you're just simply going to get just root 3. So you're going to notice there's some definite patterns between these. So just a reminder. All right, so let's look at some other ones here. Tangent of each angle. Tangent of negative 3. Ooh, this is a weird one. Okay. So negative 3/2. That's negative 1 pi, and then a 1/2 pi is going to put us right here. Okay. So these ones, when we're on our y-axis, these have a reference angle of like 90, because if you drop this down, it doesn't make a triangle, right? So these are going to cause weird things to happen. You're either going to get zeros or undefined values when you start working with this. So think of this in terms of this coordinate. This is the coordinate 0, 1. And remember how over here we said that tangent of our angle is always going to be the y over the x? So if we're doing tangent, it's going to be the y over the x, 1 over 0. Let me write this correctly. Tangent of our negative 3 pi over 2 is going to be the y over the x, which is an undefined value, right? Because you can't divide by 0. And this stuff does check out. Like if yesterday when we did these, I mentioned you can check stuff like this in the calculator, especially when you're not super confident with it yet. If you make sure you're in radian mode and you want to verify that what you're doing makes sense here, and you type in tangent of negative 3 pi over 2, you'll see it says error domain because you can't do it. It doesn't exist. Okay. So that's why it does check out and it does make sense. But these ones are weird. And that's why I kind of wanted to start with these, sort of thinking of it in terms of the coordinate. These can be helpful when you hit these ones that are on like right on your X and Y axis and stuff. So think of the coordinate when that happens. If it's in between like these, then do it as we've learned. Just do opposite over adjacent and simplify. Okay. Now it is the same thing. If you want to think of this as just your y over your x, it's your y over your x, which is exactly what we did. Same concept, just another way of thinking of it. All right. This one says 675. Okay. So what is 675? So 675, if you take away 360, leaves you with 315. Sorry, can't see that. Now you can. So 360 gets us all the way around, and then we need to do 315. So there's 180, 270, and 315 is going to put us here, meaning this is going to be a 45-degree angle because 45 and 315 makes our 360. So here's our reference triangle. We know 1, root 2 over 2, root 2 over 2 every single time. That's positive. This goes down, so that's negative. Awesome. Once that's drawn, the problem becomes pretty easy. So what is tangent of 675? Tangent is opposite over adjacent, so it's this over this. All we really got to pay attention to here is the fact that it's a negative over a positive. So it's negative root 2 over 2 over root 2 over 2. And anything divided by itself is 1. So this is negative 1. Sorry. There we go. And as you said before, if you want to check this because you're not sure, switch over to degree mode because this is a degree. And do tangent of 675 and make sure that it gives you the correct value, which it does. Again, don't rely on this though. You need to be able to do them because it really leads towards other stuff and understanding the unit circle and kind of putting all these pieces together, as well as stuff like this where you need to make sure you're getting exact values. This is the way to do it. So make sure you understand it by drawing the triangle. Okay, last example for the entire year right here. Example 4. Okay. Evaluate the secant, cosecant, and cotangent of a 135-degree angle. Okay, so it wants us to do all of them. And this isn't too bad. Remember what these are. So secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. So just as a reminder from back when we learned these back in like 7-1, that's what we're talking about. So let's draw our 135. 135 is going to be here, leaving you with a 45-degree reference angle. 1, root 2 over 2, root 2 over 2. And this one is negative because it goes to the left. That's positive because it goes up. Awesome. So at this point, we want to do secant 135, cosecant 135, and cotangent 135. All right, so secant, hypotenuse over adjacent. Hypotenuse over adjacent. 1 over root 2 over 2. That's going to invert that. So this is the same as 2 over root 2, which we need to rationalize. Been here before. Okay, so this is going to be 2 root 2 over 2, which is just root 2. Sorry. Been doing that a lot on this one. So anyway, we write it as hypotenuse over adjacent. We simplify this down by just flipping it over, rationalize the denominator, and simplify by eliminating the 2's. Cosecant, hypotenuse over opposite. So, hold on one second. My bad. This should, let me rewind that real quick. Secant is hypotenuse over adjacent, meaning this should have been a negative value. All that's going to change is it's negative throughout, and your answer is going to be a negative root 2. Okay? My bad there. Cosecant is the one we technically just did, which is hypotenuse over opposite. And you're going to notice this is the same exact thing. It's just going to be positive. So the thought process would be the same. That's going to invert this to 2 over root 2. We'd rationalize the denominator, which is going to, again, just be root 2. Positive in this case, negative in that case. And these behave exactly like their reciprocal functions. Cosecant is going to be positive when sine is positive, or negative when sine is negative. And secant is going to be positive when cosine is. It's going to match those. Okay. Lastly, cotangent, adjacent over opposite, adjacent over opposite. Really all you're paying attention to here are the signs, because you're going to have the same thing over the same thing. Just recognizing that, okay, it's going to be a -1. Very similar to the previous one that we did. These can be checked. Now, the key for checking these, we need to be in degree mode because we're dealing with degrees, and I am. And then you have to remember that this is secant is just the inverse of cosine. So if you do 1 over cosine 135, that's this, right? Because negative root 2 is the same thing. So you can check these that way in recognizing what they are. Whereas cosecant is 1 over sine. There we go. And cotangent is 1 over tangent. And so there we go. We can check all these out, basically showing that they give us the corresponding values. Okay. All right. There are 2 more of these where you're finding each of the pieces. I'm going to go through and set them up and get them kind of drawn out. And if you want to pause it and try the same, I would recommend doing so. Okay, so here is this one worked out. So 210, I went 180 and then 30 more, so 30-degree reference angle. I labeled my parts on here, recognizing they were both negative. Okay. From there, I just wrote my ratios and simplified them. So some of these are a little messy when you simplify them, like the secant one, for example. You do the hypotenuse over the adjacent. So 1 over the root 3 over 2. We invert that, and we rationalize the denominator. So yeah, it's kind of ugly. It's 2 root 3 over 3, and it's negative because the value is negative. That one I did check here and here just to show you that it does work as well, because it's kind of a weird number, but it does end up equaling the same thing. Nice way to check out to make sure you're on the right track. The other 2 simplify much nicer. You know, here you do 1 over the -1/2, which you just flip that over, becomes a -2. Here, when you do the adjacent over the opposite, invert and multiply, realize the 2's and the negatives cancel, and you're just left with root 3. So that one's not too bad. All right, same thing for the next one. I'll get it drawn up here. Okay, so this one is one of these that once you draw it, so I converted it to a decimal. I went that route. I said this is -2.5 pi. So the -2 pi gets me back to here, and then half a pi gets me a vertical going down line, which means I don't have a true reference angle here, because if I drop it straight down, it's just still the ray. It doesn't make the reference triangle. So then I went coordinate based, right? So this is the coordinate 0, -1. And then I thought back to, okay, what did we write earlier today? Remember how I wrote my little triangle? And I said, okay, this is what, so sine is always y, cosine is always x, tangent is always y over x. Well, the corresponding functions are simply their inverses, right? So cosecant is 1 over y, and secant is 1 over x, and tangent or cotangent is x over y. So I went ahead and I just rewrote those on my page just to kind of reference what those were, because they're just the reciprocal functions. So I was like, yep, secant's 1 over x, cosecant's 1 over y, cotangent's x over y. And then I just plugged the numbers in, right? I know what x and y are based off this coordinate. Plugged them in and simplified. 1 over 0, we can't divide by 0, so that's an undefined value. That's -1, and that's just 0. And yes, you can check these if you want to switch over to radian mode. So if I switch over to radian mode and I want to check like secant, I do 1 divided by cosine of -10 pi over 4. And this should be undefined, which it is. Okay. So those do all check out in those same type of manner as we did before. All right. So that does wrap it up. And this is just sort of tying together all the trig stuff into your unit circle and being able to find any of the 6 trig functions on any position in our unit circle.